Section 6 in Chapter 3 goes over molecular formulas. So in Section 5, you went over percent formulas, and in the video, you did also watch this portion. It was an older video, so I already had that made. So you should have notes already filled out here. For Section 6 here, to determine molecular formulas, remember molecular formulas have a higher ratio, so not reduced down to its lowest form. So our molecular formula, you're going to have to be given some sort of information about the molar mass, okay, or some sort of rough estimate as to what the molar mass is so that you can figure out what your ratio is. So to do a calculation like this example here, we're going to have to follow the steps to determine the empirical formula. Then we'll use this statement here, the molar mass is about 30 grams. We'll use that statement to figure out what we need to multiply our empirical formula by to figure out the molecular formula. So, compound contains 6.444 grams of boron and 1.803 grams of hydrogen. So we set up what we've been given. We want to put this into moles. So we go from grams of boron to moles of boron. Molar mass of boron is 10.81. Similar calculation for hydrogen. We want to go from grams of hydrogen to moles of hydrogen. We have 1.008 grams per 1 mole. Okay. Again, finding that from the periodic table. So for our moles of boron, I get 0.596 moles. For our hydrogen, I get 1.789 moles. Now that we've got our moles, we want our mole ratio, so we're going to divide by the smallest number. That's our moles of boron. So that's going to equal 1. I'm going to take my hydrogen value, and that's 3.0011585517, so we'll say that's approximately 3. So our empirical formula is going to be BH3. So to get our molecular formula, we want to take our molar mass of the molecular form, molar mass, divide that by the molar mass of the empirical, and that will give us our our value that we need to multiply both of our subscripts by to get our molecular formula. So we know that our molar mass of the molecular formula is about 30 grams. So we'll put our 30 grams up there, divided by our molar mass of our empirical formula. So we have 10.81 plus 3 times 1.008. And we get 13.834 grams. So that's approximately 2. And remember, we're really approximating, so let me change this here. Okay, so we're going to the nearest whole number here, whereas up here you might keep it, the nearest half. If that doesn't work out, you want to go nearest quarter or nearest third. But down here, definitely you want the nearest whole number. So for our molecular formula, We want to multiply our subscripts here each by this ratio, so times them by 2. We end up with B2H6. So that is our final answer.